Did you guys look at it?
Yeah.
Some of you have never opened the book, have you? Maria, do you know the contents of the book for this class? Huh? I'm asking you something. Have you opened the book? You don't have a book. What are we having here once again?
Hydroboration.
I don't know. You tell me. I'm just teaching here, nothing else. I don't have to know this, right? You've been testing, not me. And yes? Now, during this hydroboration, what else?
Oxidation.
Oxidation. During this hydroboration oxidation, what is going to happen is Markovnikov or Anti-Markovnikov?
Anti-Markovnikov.
Anti-Markovnikov. What was the reason why oxymercuration, demercuration was anti?
Because of the mercurium ion. Yeah.
The reason why this is anti-Markovnikov is because of steric hindrance. This is the reason why this is anti-Markovnikov. Okay. And the hydrogen will be there. Now, you can see that here you have these two things. And which side is more crowded? This carbon with only 2 hydrogens or this carbon with CH3s?
The left.
These CH3s may not look big here, but this carbon has another 3 hydrogens, okay?
Right.
Which is bulky on this side, is bulky on this side, while the hydrogens are not so bulky. So what happens is that the attack is this way, because the other way in which the boron with whatever groups is attacking on this side is hindered by these groups here.
Oh.
Yes?
Yeah, that makes sense.
So this is less hindered, so that's where the boron is going to go. Now what's going to happen is,
That's why it's that. Okay.
what is going to happen is, this here, this double bond, the pi bond, where the electrons from here are going to make a bond with this boron. Okay? Now the electronegativity on the boron is, what do you think if it gets attacked?
Plus.
Delta plus, and this is a delta
Negative.
minus. This is based on electronegativity. You don't know the electronegativity of boron,
It's less than hydrogen.
but it has to be more or less than the hydrogen.
Less.
Has to be less than the hydrogen. So the hydrogen is more electronegative, so what sign does it get?
Negative.
Negative.
Negative. This is unusual, yes? And this double bond, not this double bond, this here, which seems to be like H minus, sort of like a hydride, will then attack that carbon.
Oh.
Because this carbon, in this step, where the electron pair goes to make a bond with a boron, this carbon will then be lacking what?
Electrons.
So this will become positively charged.
Uh-huh.
So this is doing it simultaneously. Okay?
Do they do it in one step or 2 steps?
I just did it in one step.
Because of steric hindrance. Dang.
And now what we have here is this boron with bonded to that and the hydrogen there. Yes?
Yep.
So the hydrogen has successfully gone to which carbon? The one that has more hydrogens or the one that has less hydrogens?
Less hydrogen.
It has gone to the one that has less hydrogens, thus called
And
Anti-Markovnikov. Yeah.
Non-
You want to write anti-Markovnikov?
Goes against
Now,
Markovnikov.
Let's do anti-Markovnikov.
Yeah, outside. Very useful.
Anti-Markovnikov. Okay? It's anti-Markovnikov because of,
Steric hindrance.
that's right, steric hindrance. Outstanding.
Yes.
Gouch, what do you think? All right. So, this is going to do what again?
Gonna
This
be
has
negative.
the other hydrides or the other hydrogens,
Uh-huh.
and this is going to be repeated again.
Right.
Oh.
Now, the attack, now it's even worse than before, yes? Because now this boron is even more hindered than when it had 3 hydrogens, yes? So the attack is going to repeat itself, but here or there, what it's going to have is this whole thing. So this is going to happen how many more times?
2 more times?
2 more times.
To get a
Yeah.
And what this is going
Yeah.
to form those 2 more times, it's a boron, right?
Oh.
What this is going to form is this boron is going to have the carbon with what? How many hydrogens? The boron with the carbon with?
2.
I speak.
Three hydrogen.
Excuse me?
Two hydrogen.
Who cannot count in this class? Apparently most of you, huh? Look, I'm going to tell you. The boron is attached to the carbon with how many hydrogens?
2.
1 and
2.
2. Outstanding. So I'm going to put 2. And what else is attached to that? The other carbon with
One hydrogen
1 hydrogen.
and one.
And a CH3, which
One's coming back.
we can go like this, right? And it's not chiral, yes? It's not chiral because it's the same group.
Yeah.
That carbon. Well, no, it's not. No, none of them are.
Okay? And this is going to happen
Kind of lost a little bit.
again. And
Professor, why does it happen so many times? Wait, okay, that is, that completely is the two times, right?
it was already 1 time
Uh-huh.
plus the other 2, that's 3 times. So that's why there's 3.
There's 3, exactly, yeah, so that's okay.
3 times.
How did you derive that it happens 2 more times?
I did not derive this. This is what happens in real life.
So how do we know
Why
when it
2
continues?
versus 3?
Because this
versus
is
4?
what happens in real life. Why does it happen? Why don't you ask God? He made it. We made it. Huh? God made this. You didn't know?
He said that we made it.
No, we did not. So this is called a trialkylborane.
Sounds like a trial.
Kind of lost a little bit.
Why are you guys staring at the thing as if it's going to
When-
talk back?
When do you,
Kind of like lost a little bit. And to
how do
that
you,
point,
like,
I know.
how do you know when to continue? Because it happens that way, I get it. But like on paper, when we're doing the mechanism, how do you know to,
Like how many times?
yeah. Or like,
Guys,
or
please.
where it happens
Look.
more than once.
Let me tell you.
Oh, you gotta fill out-
It has 3 hydrogens, does it not?
yeah.
Look, 1, 2, 3. Each of these 3 hydrogens are going to react with how many of these?
Oh.
Oh, so it reacts as many, for as many hydrogen as it has?
Yeah.
Yeah, of course. That's why it reacts 3 times. I said it
Yeah.
reacts 3 times.
Okay.
Reacts another 2 times to form trialkylborane.
Okay.
Those things.
All right. That makes sense. Now.
Okay, you make peace with that, okay?
So that, okay.
Now that is something you have to know for the test. I'm going to ask you on the test, why is this approach like this? Why is this Anti-Markovnikov? Because of
Steric hindrance.
After you get this stuff,
Then that's the situation.
after you get this stuff, I'm going to ask you, what else do you form? And you are going to say
Trialkylborane.
because this has 3 of these, so it reacts 3 times. It's not once, but 3.
And why? Because of the hydrogen.
That's not a why.
That's a clue.
Test question.
It's like,
That's a clue.
I don't
It's a clue to
understand.
tell you how many you need to be on.
Why do you sleep?
Because we need that.
Feels good.
God created us.
Because it feels good, that feels good to it. And it needs it. That's why it does it, because it needs it. It's not because of the hydrogen. It's because it needs it.
Do we need to show the arrows, or can we just show it the first time and then show the end product?
You do what I did there. Now the next portion of this is what? Oxidation is the next portion. With what and what? Hydrogen peroxide and that's it, water? This OH minus is going to pull this proton from here. And the electrons will go there. And what you are forming here is this thing with the minus charge. It is that attacks the borane, or the borane, or the trialkylborane. Okay? So, it's going to get complicated, okay? Here is, let's say, and I just write this CH2, and then I'm going to write before I do anything else, write that down so you can pay attention to what I'm going to do.
Right next to it?
Huh?
No, like how you have it on the board, how it's right next to what you did?
Yeah.
Or like is that separate?
No, it's right next to it.
Okay.
No, okay.
Oh, that's a continuation?
Yes, I can see you have thoroughly read the book. It is your grade. I'm not going to lie to you. So this oxygen has what type of charge?
Negative.
It's negative, and this boron is what type of charge?
Positive.
Well, it's not positive, but it is
Partially
partially
positive.
It is partial
Yeah.
positive. Because the hydrogen is more electronegative than the boron, and the carbon is more electronegative than the boron as well. So this is bearing a partial positive charge. So what does the oxygen do? It attacks it. There it goes. It attacks that. And it's going to give you going to give you something like that. Doesn't look that ugly. That's a boron. That's that thing that was going to the back. Let me write it. Write it like this. Does that look like what I have drawn here? There's a new bond here on the top, right? It's gonna push these two down a little bit. Yes? So this here on the top will be this oxygen with the other OH. This here will be that group. Nice, yes or no?
Yes.
Calculate the formal charge for the boron.
No?
And Professor, you said not to worry, or that we're not gonna include whatever is left over.
No, we only care about the organic product, yes? The little things, who cares? Yes, they're there, but that's not the biggest purpose.
But in real life application, would it be like the lab that we did, that we had an organic compound and then something else left over? Is that what it would look like?
Yes. Now, what's the product here? What's the product supposed to be?
An alcohol?
An alcohol, yes? Is it supposed to be an alcohol?
Yep.
It's supposed to be an alcohol, yes? Somehow, what needs to happen? Somehow, we don't know yet, yes? This is very complicated. But somehow, this carbon here needs to have an oxygen on it. Now, there is an oxygen there. Okay, there is an oxygen there too. So what this is going to do is, this carbon here is going to attack that oxygen. Okay? And can this bond stay here?
No.
No.
Either this bond breaks or that bond breaks, yes or no? One of them has to break. They can't both be there because now this is making a bond without. Or I should say, maybe I should draw from here, yes? The electron pair from this bond is making a new bond to this oxygen. Now, this is what's going to break. So that is going to leave that way. And what you are going to get is, this boron is going to now is going to be attached to this. CH2, CH, CH3, and
CH3.
CH3. The OH left as
Negative.
OH minus. What else is on this boron here? All of this stuff CH2. So in that step, what have we successfully done? We have gone from not having an oxygen on that carbon to that carbon having the oxygen on.
Click on that OH.
You said to calculate the formal charge of boron.
Yes.
To do for what?
What's the formal charge on boron here?
It's -1.
Yes, it is negative. The formal charge on boron is negative. What's the formal charge on boron here?
Neutral.
Okay, it's neutral.
Mm-hmm.
The driving force here is boron does not like to be that way. Okay?
That's why.
So this attacks that, that decomposes, and you have this. Now, this needs to happen how many times? It needs to happen here another time, and needs to happen here another time. So I'm going to say this is going to happen twice again. What do you mean wait? This is going to happen again. It already has an oxygen on it, right? So imagine one of these is an oxygen here. And this is going to happen again for this carbon. And then we'll put an oxygen there. And it will happen again for this carbon until there are oxygens everywhere.
So the moment that oxygen attacks that boron has oxygens up there and down there.
Oxygens up there and down there. No.
Okay. Then why did you draw the O? Why did you draw the O's
Because that's the one that is doing the attack. What do you mean oxygens up there and down there?
You just put an O on the wedge and the dash.
Yeah.
And you just erase it.
Well, the oxygen is already there, right? There's an oxygen here already. Yes? Imagine, so that will be an oxygen here. And this will happen again, and then the one that is going to react is this one. And this will happen again, and the one that's going to react is this one. It's going to do the same thing. This same step, another 2 times, just like it did this 3 times.
You know how you said it's gonna happen, in that one it happens, in the beginning we did 3 times because there was 3 hydrogen on the boron, right? Can you show me, like, or count the hydrogen on?
This has nothing to do with the hydrogens. This has to do with how many carbons on the silly boron.
2.
Really, 2 carbons.
There's 3.
So how many times is it going to happen? So I can have oxygens on all carbons. 3 times. It's not difficult. 3 times here, 3 times over there.
So at the beginning you count the hydrogens, and then when you already have your first
I
oxygen,
don't know,
you
you're the
count.
one counting the hydrogens. I never said that it's because of the hydrogen.
Right.
So we leave the OH over there because the bond broke, and we just leave it up.
Yeah. The OH is swimming in the water.
Exactly, like, yeah, that's what I'm saying, like, that's just. The dash is CH2, then the wedge, and then the line, the sigma bond.
Right there is section B, then it's section 2.
Wait, so then we can put 2 more times, then we have to draw the ending.
Yeah, but
Okay, now that goes 2 more times, so then when it goes 2 more times, we're gonna have to draw like the fight, like the.
No, you have to draw the
3 on when they're
No.
No,
Guys.
with 2x, you just draw the
Then
ending.
you just draw this.
Yes, the day of the test.
Is that the way?
The day of the test. When you get here, you write twice. You don't have to redo this again. Okay?
nice.
You do have to draw this.
That 2, but we do want to know that it's gonna go through that whole step, that whole process again, 2 more times.
Exactly.
The carbons on top.
Yeah, and then at the end, we'll write 2x, and once we write 2x, we're gonna have to know what it's
So
gonna be.
the boron is going to look like this. there will be an oxygen on each of these. And there will be the rest of the stuff that was there from before.
See, that's why, because I saw that you put like the O's in the beginning over there and then you erased it, and I just didn't.
I erased it because that's not right, I write it on that one.
Because that's not the final.
Because that was what I showed initially. But after you do this many times, then this is what you get. So you repeat that process 3 times and you get an oxygen next to every one of those carbons that was attached to the boron.
So that would be our final thing on the test, or we stop at 2x.
No, you stop here,
Okay.
okay? And this is called trialkylborane or trialkylborate.
So where did the third oxygen come from?
It just repeats
Until you get to
until you get to 3.
Until you get to
From the hydrogen peroxide and the OH.
And this is in, it's in. Oh, okay. I see.
Okay, guys, do you understand that there is more of this swimming in the water?
There's a lot.
There's more of this swimming in the water, yes?
Right.
So it will do this reaction again and again and again and again. It's just gonna use 3 times. So when you're setting up the reaction, do you calculate for this 3 times or you calculate for this 1 time? You have to put enough that this will do it at least 3 times, yes? Of course, you will put tons of it, because it will do it at least 3 times. The rest of the stuff I'm not going to show, okay?
Is that something that we should learn? Or that's, we're just not gonna show?
Okay?
Because you said the elimination wasn't gonna be, like, you didn't have to worry about that, so that's why I asked.
You're only going to be tested on what I'm teaching.
So therefore he
Okay? So what's going to happen to this is this will go to what? What is going to happen at the end? That boron is going to be substituted for each of those guys. It's going to have hydrogens on it because it will form an alcohol. Okay? What type of addition is this?
Why?
Anti-addition.
It's an oxymercuration.
Look at the oxymercuration.
I wrote this.
Where's the mercury in it?
There's no mercury, so it's an
Oxymoronic, yeah.
I don't even know. I don't know anymore. It's an oxymoron.
Got you a visitor.
What's up, Anika?
We got a gift for you.
She got a gift for me?
We got a gift for you. What?
No, not now.
Why not?
No. Not now, I get shy. No.
Let's give him a gift.
No. Later. This is recording, okay?
Really?
Yeah, the camera is recording, Anika.
Shout out to all Jamaicans in here.
We have like a blooper reel at the end of the year or something.
There are no Jamaicans in here, are they? Who's Jamaican? Okay, so the addition of oxymercuration, demercuration, as far as this mercury acetate was concerned, it was
Anti.
This
Right.
addition is sin.
Sin. Yeah.
Okay? We wrote that day, yes? The
Yeah.
mechanism is not to show you whether it's sin or anti, yes?
Right.
So then what, this is sin?
Special demercuration.
Nice.
Wait.
I don't know. Because it's not. I know some.
Like most of it. Huh?
Yeah, what, no, I really don't understand why either, because in my notes, it says something completely different.
In your notes, it doesn't say something completely different.
Yeah, I have, okay, do you wanna see?
Yes, I want to see.
Can you come here? Sorry. Okay, you see what I have here? I don't know if I was in La La Land.
Yes, you were. Is this the reaction that we're talking about?
No, that's why I'm saying, yeah, so for this, right, but why, how come here I don't have sin addition?
Yeah, I do that.
You don't have sin addition from last week?
No, for sin addition, we have it
We have it
for
for
hydrogen. Yeah,
Okay, well, I'm telling you right now, it's sin addition.
What is on the same side of what?
Guys, write it down. Hydroboration, oxidation is sin addition. If you don't have it from last week, now you have it from this week.
I have sin dial. Sin, but that's not the same thing. And sin addition.
So then it's not, wait, so it's sin addition and anti-Markovnikov? It's both? Oh, well, you have
Is
one.
this the same thing as that?
So you can first.
Like, is the oxygen gonna be just like that? So I can put it on a new page? He said that.
Yeah, that is the same.
The first part was the
Yeah, put it like that, there's no continuation.
Oh, that's the same thing as that?
is sin. No, it's one thing. It's hydroboration and oxidation.
See, that's what, you're right, that's what I'm gonna confuse. That Anti-Markovnikov? That's what you meant. Yeah. That's why you said not to say that. Yeah. No, that's
It's supposed to be anti, but up to where it has the mercury there.
Yeah, but after that, the complete reaction.
It messes up, yeah.
Okay,
To that point,
yeah. Because you're going to substitute the mercury with a hydrogen, but you keep going.
but at the end,
You said that a mechanism is
Exactly. That's
That mechanism does not show whether it's anti or not. But it retains
for both.
the stereochemistry. It's retained.
We did this complete.
yeah.
Yeah.
Did you say hydroboration and oxidation is sin and non-Markovnikov? And hydroboration oxidation is that huge thing we just did, right? And the first part was the hydroboration and the second part was the oxidation. And then you can, so sin is on, obviously is on the same side, right? What on the same side of, like, I don't see what's on the same side of, like, can you show me where it's on the same side? This is what it,
No, I get what she's saying, because it does say it's in addition that it's on the same side. So then, yeah, I don't see where it's on the same side.
Because the boron and the
That the
hydrogen,
hydrogens are on the same
the
side.
boron and the hydrogen added on the same side, yes? The boron was here, the oxygen is in place of that boron. You guys want explanations?
No, it's just, I don't,
What I'm telling you is, look, I am telling you that this Does it follow Markovnikov addition, yes or no?
No.
So they call this
Anti-Markovnikov.
That could give you a misunderstanding, and you might imagine that this is anti-addition. This is not anti-addition. This is a syn addition. This is why they want to call this non-Markovnikov and syn addition. Now, it is syn addition because this boron and this hydride are adding from the same side.
Right.
And the boron is up and the hydrogen is up. This boron is replaced with an oxygen, but it stays on the same side that it was. If the boron was up, the oxygen is up. Now, can you see this in the stuff that I drew there? Can you see it? No, you can't. It's not there. So let's say that this boron here, these hydrogens that are here that have a certain stereochemistry, these hydrogens, let's say, the hydrogens are there. Yes? Hydrogens are there. There is this bond to this boron. When this makes the bond, it stays on the same side as the boron was. So if the boron was on the top now, when it bonds to this oxygen, it'll still be on the top.
Oh, okay.
Okay? It's not shown there, because that would get crazy. Yes? This is showing what happens to the bonds. This is not showing why it's in addition. Okay? So if that were like that, and that bond is there, the other one will still be on the same side that the boron is. Okay? That's why it adds to the same side. Because at the beginning it was like this, yes? The boron and the hydrogen. You see it? Yes or no? So the boron and the hydrogen. At the end, when this does whatever reaction it does, this boron will be replaced with the oxygen, still where the boron was. Yes or no?
Yes. The oxygen where the boron was, yeah.
Of course, it's not going to look like this, yes? So, the purpose of this question is not to do the mechanism. The purpose of this question is for you to give me the products only.
Yeah.
A mechanism is a mechanism and the product is the product. So give me the product based on what you know. Okay, what is this going to give me? What's going to go where? Here's the CH3, yes? And the other CH3 is going to go where?
I mean that.
Why is it going to go to the dash?
Because it's sin.
Because, well, what is syn addition is not the groups that are there, even though they have to be syn, yes?
Right.
What is going to be syn addition is that the hydrogen that came in and the
replace the
oxygen with the hydrogen that came in or the alcohol will be on the same side.
Okay.
You can put them here or you can put them on the dash.
Yeah.
Okay?
But this, you always put on bottom. It doesn't matter. Because it's anti, but they're both.
How about here?
equally the same amount of
Bottom,
hydrogen.
on the
bottom.
Where's the OH gonna go to?
On the bottom.
The bottom.
Syn
Gonna go
and
here.
anti-Markovnikov, sorry.
So if I put DOH here, where's the hydrogen going to go?
On the dash.
And here,
CH3,
here?
CH3. H.
it's another hydrogen. Okay?
So,
And of course, we can have it on the wedge, yes?
Mm-hmm.
We can have the OH in the wedge.
the bottom is showing non-Markovnikov and syn.
Yes.
Where at the top, we can only say that it's syn because it doesn't matter.
Yes, here on the top, we cannot look at Markovnikov. This is not Markovnikov because it has the same thing on both sides, but it still will have. So what you have is here, this is called syn. This reaction is syn addition. This is